So, welcome to Containerizing Your Monolith. So, who I am, my name is Jano González. I work as a production engineer for SoundCloud. I've been working for SoundCloud during the last almost 6 years. I started as a backend engineer, and then in some point last year, I wanted to know how the sausage is made. So, here I am. So, as many companies, in some point we started moving from a monolithic architecture to microservices. But what happens when your infrastructure starts to diverge? So you have the new and fancy microservices world, and the old and non-exciting monolithic world that no one wants to touch anymore. So this talk is about the experience about containerizing this monolith to run it in the same Kubernetes infrastructure as our microservices. So what's SoundCloud? Download it right now. It's a pretty cool audio app. Let me put my marketing hat on. I've heard you like numbers here, so we have more than 200 million tracks made by more than 20 million creators. But those numbers are not that interesting for me. What's interesting for me is, for example, the huge pop culture impact of the many SoundCloud rappers we have. If you don't know what a SoundCloud rapper is, ask the next Gen Z person you see on the streets, they will know. So marketing hat off, engineering hat on. So what's the motivation for this talk? So this is part of some work I did during 2017 and 18, and I didn't think it was exciting enough to write about it or even present it in a conference. But then a couple of people in the same migration situation contacted us about our experience putting our monolith in Kubernetes. So I thought maybe this is something worth sharing with people. Because when you are a small company, let's say you are big enough to migrate to microservices, but you are not big enough to migrate in a short time. So many people needs to keep moving, keep delivering features, so you can't afford a big bang migration. So what do you do with your monolith in the meantime? So the main takeaway is what's the balance? How much you invest in your original monolith and how much you invest in your microservices architecture. So this presentation is organized in 4 sections. So first, I will tell you a little about our migration to microservices, just to put things in context. Then I will describe our monolith. And then the main course, how we containerized our monolith. And finally, I will share some learnings and reflections about what we did. So, as advertised in the previous slide, let's start with our journey to microservices. So, like any company during the previous decade, we were like, what's the name of our company? SoundCloud. OK, Rails new SoundCloud. Welcome to your Rails app. Probably the command wasn't Rails new in that version, but who remembers anymore? But new decade, new challenges. So around 2012, we introduced our new web experience. We called it SoundCloud Next. That was the marketing name. Internally, it was just V2, the second version. A single-page app that consumed an API, just like many apps back in the day. And this public API exposed all the domain logic that was inside our monolith to also third-party apps iOS and Android clients, and also the new website. But delivery became a little slow, so the monolith became a bottleneck because so many teams wanted to ship so many exciting features at the same time that the cost of delivering became too high. So a lot of people wanted to deploy the monolith at the same time. People wanted to change the same part, etc. So in some point, our engineers thought, what about a microservices architecture? So new features, new exciting services. For example, messaging was extracted into a microservices and other things. And of course, microservices still need to know about some entities that live inside the monolith. So we added, we call it semantic events bus or broker. No one calls these things semantic events. I don't know why we do it. They are just life cycle events. User posted a new track, user followed a new user, etc. So that way, microservices can know about what happens with the entities inside the monolith. But sometimes these microservices also need to know about things inside the monolith without getting notified. They need to do RPC against endpoints in the monolith, so we had to introduce also an internal API. So as you see, to support this microservices architecture, the monolith also became a little more complex. And eventually, we realized that having one public API for each user experience wasn't probably the best idea. Also, Rails 2 wasn't the best orchestrating calls to many different services at the same time. So in that point, we introduced what's called the BFF pattern, backend for frontend, which is basically an API gateway that provides a specific, let's say that powers a specific user experience. So for example, in web, probably you need richer representations of every entity, but on mobile, you need lightweight ones, etc. So each one of those, it's one API. And in that point, we started using Finagle, this great RPC framework by Twitter, and all our services started being written in Scala. So that takes us to the current situation. Of course, this is the typical idealized architecture diagram. You don't even see some bots that says monolith still here or anything. So, but as you see, we have many, many microservices. Some of them do, let's say they are value-added services, so they power some specific use case. Others are what we call foundational services, which just serve metadata from important entities, etc. So many microservices, hundreds of services. So what about deployment? So for deployment, we have just a couple of abstractions because in some point, we had our own container orchestration suite called Bazooka. And in some point, we wanted new features, and Bazooka, let's say the cost of improving Bazooka versus adopting something that was already there and mature enough, like Kubernetes, made us decide for Kubernetes some years ago. But in terms of deployment, we kept the same abstractions, so all our internal tooling, it's pretty similar to the times when we used Bazooka. And now we just map these concepts into Kubernetes objects or abstractions. So in our case, one service, it's one code base usually. that has many components. So those are, let's say, entry points for each one of your containers. So for example, our follows service exposes an API. That's one component, but also has an events consumer that when users, for example, are removed from the platform, it will also remove the follows in the database. So it has two components, for example. And we have the concept of environments. Unlike many companies, we ship our configuration with the container. We don't do configuration in runtime because it's better for us. I guess we had too many outages with dynamic configuration in the bazooka times. So now we just ship the configuration. And recently, we introduced the concept of zones, which is a failure domain, basically. So in Kubernetes terms, one zone will be one Kubernetes cluster, for example, one on-premise, another one in the cloud, etc. So basically, we map these concepts to Kubernetes concepts. So the combination of a service and an environment is a Kubernetes namespace. A component is a deployment with its own rollout set. I forgot the names of Kubernetes components. You know more than me about that, but yeah. So that's the infrastructure. A huge Kubernetes cluster houses the deployment. You merge something to the master branch. Behind the scenes, you run a couple of makefile targets that use our internal tooling that in the end just package an image, publish it, and deploy it to Kubernetes. So what about the monolith? So as you see, this monolith was left behind not once, but twice. First, new fancy Scala Finagle services versus this old Rails app left behind once. Then left behind twice because new fancy deployment pipelines, the monolith still deployed with Capistrano. So let's see what's the monolith. So this is surprising to some people, but our monolith still serves some of the core entities and use cases of our platform. So for example, tracks, users, and playlists still live inside this monolith. And what's an audio platform without tracks? It's nothing, right? Also, we publish lifecycle events for these entities. We have these reversible deletion systems inside the monolith. And we expose all these entities and its use cases to internal and external clients. So now it comes the exciting part, the technology. So back in the day, it was 360 bare metal machines provisioned with Chef. The monolith is still a Rails 2.3 app, probably one of the largest still useful Rails 2.3 apps in the world. And it was deployed with Capistrano. What's the architecture? This is a simplified diagram. Everything in orange, it's part of the monolith, different components. They share the same logic. So they just expose some domain logic to different audiences. So we had public web, a couple of views that didn't make it to the fancy one-page app. We had our public API and our internal API and some workers doing things behind the scenes, not on the serving path. We have a couple of friends. So the internal API has also a caching layer in Scala that it's in front of it. So other microservices usually go to the caching layer first. We also have a public API strangler. This is the strangler pattern. That's a whole topic for a different talk. And basically, it proxies the public API with the hope that in some point, we will destroy this public API and we will just orchestrate microservice calls. And we have other VFFs, or other of those API gateways, for example, API mobile, etc. But this is the simplified diagram. Actually, the monolith, it's a ton of components, public API, public web. We have even some assets hosts. This is pretty funny because in some point we realized we were wasting 64 cores to serve some assets that are used once per minute or something. And we have actually 2 internal APIs, one called Moshi Moshi, because we call the monolith mothership, by the way, so that's why it was Moshi Moshi, the internal API. It's kind of similar. We had an extra internal API just for comments. We had workers. We had a machine just for running cron jobs. So there's a couple of rake targets in the monolith. For people who doesn't do Ruby, rake, it's like make, but in Ruby. We had a shell machine, so the monolith was deployed there, so you can open a Rails console against production and run scripts, and even a migration host where you run database migrations. So it's a lot of stuff inside the monolith, and each one of these bare metal hosts contain the component and a couple of run it services, which were mostly used to expose metrics. So there are some issues with this monolith. First of all, utilization. We were not using our bare metal machines efficiently, and during 2 years, we forgot to do capacity planning, so we were hugely overscaled. Deployment was an issue. When you have deployment pipelines that deploy everything automatically, people tend to avoid running this Capistrano command, especially what happens when one of the machines fails and you have to retry. Rollbacks were not that friendly as just rerunning an old pipeline. That derives into a lack of confidence for teams because people is afraid to touch the monolith. No one wants to be on call for the only thing that it's scaled in a weird way, provisioning more bare metal hosts instead of just running a scale command. No one wants to be on call for the thing that aggregates logs in a different way. You get it, right? I guess no one wants to be in that situation of having all this shiny architecture, but sometimes having to deal with this ugly old code base. So we describe our migration to microservices. We describe the monolith. So I will tell you now how we containerized our monolith. Well, it's actually pretty easy. You throw it into Kubernetes. Congrats, your monolith is a microservice now. Thank you. Sadly, as especially sysadmins know, things are not that easy in the real world. The world of slides, it's way different to the ugliness of the real world. So let's start with the project. We were 1.5 engineers. Yeah, we don't have half people in our company. It's just parental leaves, sabbaticals, etc. And it took us 1 year since we started until we cleaned up the last bit of the old stuff. So it was between 1 and 1.5% of all engineers during 1 year. So, of course, we didn't wait for 1 year to reap the benefits. We were delivering step by step. So now I will show you all these steps we did. So the first milestone. Our first milestone was quite easy, just creating a Dockerized development environment. That was a huge win for us because first we were able to decommission our old Jenkins, how do you call it? Pipeline, yeah. We didn't call them pipelines back in the day, but yeah. So it was pretty much the last thing running in the old testing infrastructure. That was already a huge win. You always like to decommission stuff. So, of course, deployment was still manually triggered. We just containerized the development environment. We run the tests now in GoCD, our new pipeline system. But still, deployment was manual, or manually triggered. Then it came the proof of concept. Can we even run this in our architecture? Sorry, our infrastructure? So we deployed the first staging component, which was this Moshi comments API, which is a simple API that just serves threaded comments. That should be fairly easy, right? But we had our first problem. You will see in the corner problem and solution labels as a visual cue for you. So the way we ship our containers is that we ship a configuration file, and then your entry point for the container is an initializing script that will source this environment file, will decrypt stuff that it needs to decrypt, and then it will pass this environment to the next executable. In this case, it passed to Nginx. Nginx passed the variables to Passenger. Passenger spawns up many processes because we couldn't run in multi-threaded mode. And Passenger processes pass the variables to your Rails app. And in some point in the way, variables were lost. Because environment variables needed to be configured in the Nginx config file. But how do you pass the dynamic variables? So some people, when confronted to a problem, sometimes say, I will just use Perl. That's my kind of people. So I just did the infamous Perl hack. So we created a template for our Nginx config files that will declare a bunch of variables. And then, using Perl set, it will read the variables from the environment and configure them so they will be passed when the application starts. The code is not important. This is more about the experience. Please don't try to do that. I'm sure I will go to programmer's hell when I die for doing stuff like this. Then we productionize the app. Because one thing is running it, but does it run in the place where it matters? Production. So we had to deal with the deployment, monitoring, logging, etc. In order to do that, this is something we couldn't do, for example, with our old container orchestration suite. Because in Kubernetes, one pod can be many containers. One is the main container, and you can have sidecar containers. So we ran our component, and all the stuff we used to have as run-it services on bare metal, it's now a bunch of sidecars. So all our stat exporters are sidecar containers now. So our Prometheus server can scrap metrics from each pod. Then, when you have your pods well configured, we shoot against our foot again, because in SoundCloud, we tend to overuse DNS for some stuff. So for example, our client-based service discovery, it's based on DNS, SRV records, etc. So if you have too many pods, your DNS responses will be too big, and you will choke service discovery. So you can't have too many pods. If you have 1,000 pods, if I ask, give me all these, all the pods for this component, you will get huge responses. On the other hand, you can't have pods that are too big because you need them to be allocatable. So you need to have enough resources in your Kubernetes cluster to actually allocate space for those pods. So after 2 many super scientific metrics. In our case, what we did was assign 3 CPU units for the main container and run inside it 16 passenger processes. How we arrive at that, I don't even remember. We learned from Brenda and Greg that all benchmarks are wrong anyway, so we were ready. But no, sadly, another problem. In the containerized world, of course, you want to send your logs to a standard output. So if you have any log aggregation, it's super easy to aggregate all those logs, of course. No one does file logs in containers. It's like, oh. But one of our metric exporters is mtel, which is a log parsing utility that then it's able to expose Prometheus metrics based on regexes in your logs. So I had the problem of, oh, damn it, and I don't want to run mtel outside my pods because if there's any interruption, I don't want to run blind. So the rotate logs hack, of course. Just don't do this. It's the last resource. So I had to multiplex standard output also to a file. That file needs to be rotated. Otherwise, you will start using too much space. So our log aggregation can get logs from a standard output, and mtel can expose metrics based on the log file. That's the things you have to do sometimes. So then it came the problem of, oh, now we need to productionize public API. What's special about public API that it needs to orchestrate calls to other services. So more problems, DNS latency. We overuse DNS in SoundCloud, I already told you that. And our Rails monolith, every time it needs to use a service, it will issue a DNS query for that service. So production engineering, the team where I am currently working, but I wasn't in that team back in the day, they first migrate the whole Kubernetes cluster to core DNS. Things were way better, but performance for me wasn't still enough. So I just did a DNS hack. So in my case, I did a small, the code also doesn't matter, it's just some Ruby code, but basically to search for less things in our DNS. So I simulate that records have a point in the end. Probably there are way better ways to do something like this, but I didn't know better, so DNS was fast enough now. And then the last huge challenge was productionizing our internal API. Why? Because it's the highest throughput component of this monolith. So I was already sure that problems were along the way. So problem, of course, latency was too high. It may come as a surprise, but containers are less efficient than bare metal, especially a super over-provisioned bare metal cluster. I did my best to optimize the environment where the app runs, but as a backend engineer that I was back then, I didn't know so much stuff. I did my best to optimize the garbage collection settings. I mean, in Ruby 1.9, there's not much you can actually do compared to newer versions. And Rails creates a lot of new objects per request, which is pretty bad for garbage collection. I did my best, but as a backend engineer that I was, I will just solve it with programming. So I took all the most used endpoints and I tried to optimize, especially SQL queries, to go less times against the database. For example, mistakenly, as a happy accident, I reduced by half our usage of MySQL replicas, which was a nice win. And our internal API was fast enough again. But as I started rolling out more traffic, I noticed that every time we deployed, I had a couple of error spikes. So I thought, this must be that when I shut down one of the pods, the kill 9 that it receives doesn't let it finish everything. So I use the pre-stop trick to run something before the pods are stopped. So it sends a graceful shutdown, has even some sleep for 15. Also going to programmer's hell for this probably. So I was like, oh, OK, problem solved. I can go home. Oops, error spikes during deployment. Again? Because pods also need to start during a rollout. So in this case, I did the pre-start trick. So basically, Passenger creates a bunch of processes, and some of them were not warmed up when I started sending traffic because I had a disconnection between my readiness probe that says Kubernetes, I'm ready to receive traffic, versus when the app was actually ready to receive traffic. So only one of the processes was ready to receive traffic, not the other 15. Sadly, in Passenger, probably, I don't know, maybe nowadays it has something to do this, but it doesn't have a signal that tells you I finished pre-starting everything. So what did I do? I measured the time, and I added an initial delay for the readiness probe. Going to programmer's hell, now for sure. So the rest of the things were not that interesting, but the workers, we just spawn up stuff consuming from RabbitMQ. Things were OK. We decommissioned the old infrastructure. Instead of having this cron jobs shell and migration hosts, we run stuff from the package images. And of course, we clean up our stuff. You don't finish a migration after you clean up all your mess. This is something that many engineers still don't know in this year. So finally, in September 12 last year, the historical moment where we removed the last piece of code that still references our old deployment. So what's the current status of our monolith? On-prem, we ran around 1K pods it's a sum of the different components. Some of them serve internal traffic, others external traffic, and others don't serve any traffic, just consume messages and do stuff. In the cloud, we run 140 pods. And the traffic we handle with those, on-prem during peak time, around 25K RPS between all components. In the cloud, just 3K. And the most important part of the current status is that this is too small for you to see, but you can see that this monolith was deployed many times a day, just like any other microservices we have in our company, which is a huge win. So, some conclusions. What we solved? The problem to have just one infrastructure. Also, just one delivery process. So now everything runs in Kubernetes. Everything is deployed with this deployment pipeline that's activated when you merge to the master branch of a project. How we did it? Step by step, of course. Do you remember New Kids on the Block? Great song, by the way, right? With controlled rollouts. So that's fundamental when you do such a huge change. We had to run in still bare metal and Kubernetes at the same time and roll out slowly traffic so we can roll back in case of problems. And it's pretty important. That doesn't look like a mountain, right? You need to manage expectations. You have a huge mountain to climb. You will have different problems than me, but I'm sure you will have problems doing something like this. And you need to manage the expectations. This is not something that can be just done in 1 quarter, I guess, on any company. Maybe you're pretty smart people. Maybe you can do it. So what were the benefits of this migration? First, infrastructure was pretty excited about this because improved utilization. Now all those hosts were thrown into our Kubernetes cluster, and we improved utilization now. We can use only what we really need to use. But what's really important for me was improved confidence. People were not afraid to touch the monolith anymore. And that enabled new initiatives also. So when we did the multi-datacenter migration to run on-prem and cloud at the same time, we just had to use our tooling, and the monolith was already multi-datacenter compatible for us. Also, it allowed us to improve critical components in a safe way. You just run 2 versions in parallel. I mean, you can do that in Capistrano too, but in Kubernetes, it's so easy to run multiple versions of something. And something I'm really happy, it enabled me to create an ownership RFC, so I can split the ownership of this monolith, and people at least see that it's just another app, just with a really old technology, but you service it, you operate it the same way than any other app in the company. So why you are all here? Should you do it? I don't know, sadly, but what can I tell you? First, you need to assess your current progress. How long until we are off the original monolith? And then you need to evaluate the costs and benefits. There is a hidden cost of having the monolith just lying there that can make you slow down your migration to microservices. Because if people is afraid to touch the monolith, they will be afraid to extract things out of it. And sometimes you create workarounds to avoid working with the monolith that make the migration even harder. So give it a thought. Maybe having your monolith in the same fancy infrastructure than your microservices may be worth for you. Thank you. And just. And if you have similar experiences, just ping me on Twitter, Jano González, or in the hallways. We can do some video calls. I'm happy to share what we have learned during our journey. And the moment that makes this all worth for me, I can promote my own songs. I'm also on SoundCloud. Thank you, everyone.
Oh, thank you so much. I believe we have time for one question. So if anyone wants to come up to the microphone.
Hello. Monolithic application means that you have monolithic database. How you solve monolithic database problem in multi-regional deployment?
So basically, every time we extract a microservice, we also extract the data into its own database. That introduces problems of eventual consistency. That's why we also publish lifecycle events, because let's say the follows database only knows about what user follows what user, but it doesn't know if a user was removed from the other database. So you need a mechanism to let know all your services about changes. Also, sometimes we export data sets, so we can merge databases from different sources in our warehouse, which makes stuff like reporting, how to pay each artist easy, because otherwise it will be impossible with all the data scattered around the app. So you need to embrace eventual consistency, basically.
Thank you. All right. Oh, thank you so much.
Thank you.